Good evening. My name is Vishakha Agarwal, and the topic we have chosen for our natural language processing J component is secure authentication using voice recognition. So, we'll talk about our problem statement, description, pros and cons of voice recognition, and our approach with this model. So, first, we'll talk about the problem statement. So, voice recognition or speaker recognition is the ability of the machine or program to receive and interpret dictation or to understand and carry out spoken commands. Voice recognition has gained prominence and use with the rise of AI and intelligence assistants such as Amazon's Alexa, Apple's Siri, and Microsoft's Cortana. Voice recognition systems enable consumers to interact with technology simply by speaking to it, enabling hands free requests, reminders, and other simple tasks. So, now we'll talk about voice recognition in detail. So, how voice recognition works? Voice recognition software on computer requires that analog audio be converted into digital signals, known as analog to digital conversion. For a computer to decipher a signal, it must have a digital database or vocabulary of words or syllables, as well as a speedy means for comparing this data to signals. The speech patterns are stored on the hard drive and loaded into memory when the program is run. A comparator checks these stored patterns against the output of the analog to digital converter, an action called pattern recognition. In practice, the size of a voice recognition program's effective capacity of, of effective vocabulary is directly related to the random access memory capacity of the computer in which it is installed. A voice recognition program runs many times faster if the entire vocabulary can be loaded into the RAM, as compared with searching the hard drive for some of the matches. Processing speed is critical as well because it affects how fast the computer can search the RAM for matches. While voice recognition technology originated on PCs, it has gained acceptance in both business and consumer spaces on mobile devices and in home assistant products. The popularity of smartphones opened up to the opportunity to add voice recognition technology into consumer pockets, while home devices like Google Home and Amazon Echo brought the recognition technology into living homes and kitchens. Voice recognition combined with the growing stable of Internet of Things sensors has added a technological layer to many consumer projects that previously lacked any smart capabilities. As uses for voice recognition technologies grow and more users interact with it, the companies implementing voice recognition softwares will have more data and information to feed into the neural networks that power voice recognition systems, thus improving the capability and accuracy of the voice recognition products. So, these are some uses of voice recognition. The uses of voice recognition have grown quickly as AI, machine learning, and consumer acceptance have matured. In home digital assistants, from Google to Amazon to Apple, have all implemented voice recognition software to interact with users. The way consumer uses voice recognition technology varies depending on the product, but it can also include transcribing voice to text, setting up reminders, searching the internet, and responding to simple questions and requests, such as playing music or sharing weather or traffic information. The government is also looking for ways to use voice recognition technology for security purposes. The National Security Agency has used voice recognition systems dating back to 2004. We can talk about the pros versus cons of voice recognition. So, voice recognition enables consumers to multitask by speaking directly to their Google Home, Amazon Alexa, or other voice recognition technology. By using machine learning and sophisticated algorithms, voice recognition technology can quickly turn your spoken word into written text. Now, while accuracy rates are improving, definitely, but there are still room for error. Background noise can produce false input, which can be avoided by using the system in a quiet room, but it is not always possible. There is also a problem with words that sound alike but are spelled differently and have different meanings. For example, here and here. They are spelled differently, like HEAR and HERE, but they mean entirely different. This problem might someday be largely overcome by using stored contextual information. However, this will require more RAM and faster processors that are currently available in markets for PCs. Now we'll talk about our approach and our model. So, speech and voice recognition are the emerging scope of security and authentication for future. Nowadays, text and image passwords are prone to attacks. In case of the most commonly used text passwords, users are required to handle different passwords for emails, internet banking, etc. Hence, they tend to choose passwords such that are easy to remember. But they are vulnerable in case of hackers. In case of image passwords, they are vulnerable to shoulder surfing and other hacking techniques. Advances in speech technology have created a large interest in practical application of speech recognition. Therefore, this system provides our users with the appropriate and efficient method of authentication system based on voice recognition. Humans are always comfortable to communicate in their natural language. Communication is an integral part of human life, also a symbol of identity and authorization. Speech and voice recognition are the emerging scope of security and authentication for future. Nowadays, text and image passwords are prone to attacks. Due to there being a large number of passwords that users have to remember, users tend to use passwords that are easy to remember, like their names, they include their names in the password and so on. So this makes them vulnerable. And using voice recognition, we can eliminate that memory factor and it will just solely depend on their voice. Voice recognition is also known as speaker recognition, and it applies the analysis of a person's voice to verify their identity. Airways and soft tissue cavities, as well as the shape and movement of the mouth and jaw, influence voice patterns to create a unique voice print. It's different to speech recognition, where AI focuses on words rather than voice. There are two main approaches to voice authentication. One is text independent, where the voice authentication is performed using any spoken passphrase, and there is text dependent, where the same passphrases are used in enrollment and for verification. This means that a speaker cannot say anything he or she would like to authenticate, but they will have to use a specific phrase. In static text dependent voice authentication, the same passphrase is used for every verification. In dynamic text dependent voice authentication, a randomized passphrase such as a number sequence is generated. But generally, we prefer a static text dependent verification. In our project, we will be creating a two-factor authentication system using voice recognition. We will be extracting over 15 different Mel frequency substral coefficients and comparing against the same by formulating our own statistical model. Using these features, we will determine if the specific candidate logging in is authorized to do so. The different coefficients will allow our system to validate every user and ensure that the login is adequately secure. We will develop a secure web app which can be used as a plugin and be integrated by various other systems. To ensure the integrity of the project, we will be using MongoDB cluster to store the user's Mel frequency substral coefficients and provide a second layer of added security to prevent data breach. Due to the lack of a robust two-factor authentication system, data and security can always be compromised. Using our two-factor authentication system, we aim to provide a solution to this real-world problem. Thank you.